All right, well, welcome to your lesson on cyclohydrocarbons. We're going to start off by talking about cycloalkanes, which means all single bonds between carbons, and then we're going to get into cycloalkenes, double bonds, and cycloalkynes that have triple bonds. So when I have cyclo shapes, what cyclo means is essentially circle or closed ring. So what I have here is something where I have carbons all connected in such a way that they end up making a closed shape. And this is a really ugly hexagon. But for example, if I had carbons all connected with single bonds, making a closed shape like this, that would be then a cycloalkane. Cycloalkanes have the general formula of CnH2n. I've lost two hydrogens, right, from the general formula for a normal alkane in order to make that closed shape. So to name a cycloalkane, what you do is you count the number of carbon atoms in the ring. This is your parent chain. The parent chain only includes the cyclic structure. It cannot go outside of the cyclo structure that you have. So it's just the closed shape that is your parent chain. Everything else coming off of the parent chain is now a branch. You are going to number the atoms, the carbon atoms in that circle shape, that ring shape, in order to get the lowest numbers possible for the branch that is alphabetically first. So you're going to start with the branch that's alphabetically first, and that's going to be your carbon number 1. And then you're going to figure out whether you go clockwise or counterclockwise around that shape in order to get the rest of the branches at the lowest number possible. So it's just like the other, that we try to reach the first branch that we possibly can first. And then, yeah, we're just trying to get the lowest number possible from there. We name branch position and size of the branches the same as in alkanes, and then add the prefix cyclo to the name of the corresponding ring structure for our parent chain. So for example, if I take a look at this particular structure, I have 1, 2, 3, 4, 5, 6 carbons, right? Nice line diagram here, 1, 2, 3, 4, 5, 6. So this is going to be cyclohexane. Cyclo means I have a closed shape, and then hexane means that I have 6 carbons in that closed shape. When I take a look at this one now, I've got a closed shape with 1, 2, 3, 4 carbons. Now it doesn't matter which direction I go as long as I start with one of these as carbon number 1. They're both ethyls, so it doesn't matter which one I start with. So if I started, let's say, with here, then my numbering would be 1, 2, 3, 4. Obviously better than 1, 2, 3, 4, where I reach the branches on 1 and 4. I want 1, 2, 3, 4. So going counterclockwise in order to get the numbers that I want. If I would have started with this one at 1, then I would have gone clockwise. 1, 2, 3, 4. Same way, right? Same name either way. So I have 1, 2, diethyl, because I have 2 ethyl groups, 1, 2, cyclobutane. All right, when I look at cycloalkenes and cycloalkynes, the double or the triple bond that is going to be part of your closed ring, that takes priority, okay? That is carbon 1 and 2 for your numbering. It has to be 1 and 2 for the double or triple bond, no matter what. Now you can decide which of the 2 carbons is 1 and 2, right? So you could go clockwise or counterclockwise, but 1 and 2 for numbering have to be on either side of that double or that triple bond. When I'm dealing with a cycloalkene, the general formula is 2n minus 2. Cycloalkyne, it's 2n minus 4. So essentially for each thing, I'm losing 2 hydrogens, right? For a cyclo, I lose 2 hydrogens. When I have a double bond, I lose 2 hydrogens, and then a triple bond, I lose 4 hydrogens from the general formula. But naming, really not too bad. I've already talked through this. We need to make sure again that for the double or the triple bond, it's carbon 1 and 2, and this is going to be a part of the cyclo shape. Now, that being said, I need to still put the multiple bond position there, but sometimes we actually skip it in the name because we always know that that double bond position is going to be carbon number 1. So we can leave that out. It's a choice that you can make, but I think it's just better for our work to always just kind of leave that in so we get into the habit and we don't forget to do that when we get outside of cyclos. So if we take a look at a shape like this, right, I have two different naming way or numbering ways that I could do. I could do 1, 2, 3, 4, etc. Or let's go all the way around here and then go with a different color, 7, 8. Or I could go numbering instead, we'll use red for this, as 1, 2, 3, 4, 5, 6, 7, 8. And you can see that red is the better choice by going 1, 2, and notice that the 1 and the 2 is on the triple bond no matter what. But then I reach a branch at 3, right, instead of reaching my next branch at 4 for the black. So that is a better choice. So my name for this would be 3,7 dimethyl cycloalkenes. I think it's interesting to break down each part of this. So the 3,7, I should get rid of that black marking to make it less confusing. That 3,7 dimethyl, that's pointing out this one carbon branch and this one carbon branch, right? So di, because I have two branches, and the positions on this is carbon number 3 and carbon number 7. I have cyclo, which means closed shape for the parent chain. Oct, because I have 8 carbons. 1 ine, carbon number 1 is where I have my triple bond, and it is a triple bond, hence the Y in the ine shape. All right, this one right here, this is interesting because if I number this, I could go 1, 2, 3, 4, 5, or if I go to a different color, let's use green this time, I could go 1, 2, 3, 4, 5. So what color do you think is better in this case? Should we go with red or should we go with green? And the answer is we should go with green, given that green has a branch on carbon number 1. So 1, 2, 3, 4, 5. So I'm going to have 5-ethyl, one, 3 dimethyl cyclopent 1-ene. So 5-ethyl 1,3-dimethyl cyclopent 1-ene. Okay, that is it for dealing with the naming of cycloalkenes and cycloalkynes. After that, we just have our work to get through, just double checking that we're all good here. Yeah, now we got a lot of work. So I'll leave you with that. Give it a try. Enjoy the rest of your day.